far beyond the quiet blue arc of Earth, past the inner planets, and drifting through the thin, cold sunlight between Mars and Jupiter, something is approaching. It does not belong here. It is not a comet born from our solar system. It does not orbit our sun, and it does not follow the rules that normal comets obey. This is 3I Atlas, the third confirmed interstellar object ever observed by humanity. A traveler that has crossed the emptiness between stars, and now, in December 2025, passes close enough for us to study in detail. On December 19th, it reaches its closest approach to Earth, not close enough to threaten us, but close enough to reveal secrets we may never have access to again. What could happen on that day? What will scientists see? And what clues could this fading, rotating, shape-shifting comet leave behind about the worlds that exist beyond our sun? Tonight, we break it all down with real physics, real observations, and the mysteries still remaining. 3I Atlas was discovered earlier this year, and immediately astronomers noticed something unusual. Most comets follow long, stretched ellipses. They circle the sun, return again, and leave recognizable patterns. But this one? Its path is hyperbolic, the unmistakable signature of an interstellar object. That means it came from outside our solar system, it is moving too fast to ever be captured, and once it leaves, it will never return again. Humanity has only seen two visitors like this before. One Oumuamua in 2017, 2 Borisov in 2019. But 3I Atlas is different. It is passing closer to Earth than Oumuamua ever did, and moving slower than Borisov, giving scientists a rare window to observe alien material at high precision. Every interstellar object is like a sealed letter from another world, a fragment of an ancient planetary system frozen for millions of years and then flung into the galaxy. December 19th is when we get to read that letter. Astronomers call it perigee, the moment 3I Atlas passes closest to Earth. No danger, no impact, just proximity. But the real excitement comes from geometry. On this day, the alignment between the Sun, Earth, and the comet creates perfect observing conditions. Sunlight passes through the comet's coma, the expanding cloud of gas around its nucleus, and reveals details usually impossible to measure. During these hours, scientists can extract chemical fingerprints of the gas temperature, dust rotation patterns, jet activity, mass loss, the internal structure hidden beneath the surface. In simple terms, December 19th is not an event. It is a window, one of the best observational windows for any interstellar object in history. And through that window, something extraordinary may be waiting. One of the most puzzling mysteries astronomers are studying is what they call the dimming paradox. Comets normally brighten as they move closer to the sun. They heat up. Ice turns to vapor. Dust explodes outward. The coma expands, and the comet glows more strongly. 3I Atlas did the opposite. From late October through early November, the object began fading, even while moving towards stronger sunlight. Several explanations have been proposed. The comet may have already lost most of its surface dust early in its journey, leaving only darker, heavier material that reflects little sunlight. If its active jets suddenly shifted direction away from Earth, the comet could appear dimmer even while becoming more active. This is an interstellar object. It may contain ices that behave differently than anything in our solar system. A crust layer may have collapsed, sealing vents and reducing its reflective area, and yet, none of these fully explain the observed decline. This is why December 19th is critical. By studying its brightness during closest approach, astronomers will finally learn whether the dimming stops the comet stabilizes or the comet suddenly reactivates under stronger solar heating. Each outcome reveals something different about the chemistry of alien comets and what kinds of worlds exist beyond our sun. Another surprising discovery is the object's 16.16-hour rotational pulse, a repeating variation in brightness known as its heartbeat. In normal comets, this brightness rhythm is caused by rotation. As different regions face the sun, their activity changes. But 3I Atlas shows a heartbeat that is unusually strong, shifting in amplitude far more dramatically than typical comets. This could indicate highly uneven active regions, an elongated or bizarrely shaped nucleus, fast-evolving surface chemistry, or a fractured interior rotating in a complex way. On December 19th, telescopes around the world, including JWST, Hubble, the VLT arrays, and radar facilities, will track this heartbeat with the highest precision yet. If the pulse strengthens, weakens, doubles, or breaks apart entirely, it could mean the comet is undergoing internal changes as it warms. If it remains stable, it means its strange brightness variations were simply geometric, caused by orientation, not disruption. Either way, the heartbeat will teach us how an interstellar object holds itself together. The tail of 3I Atlas has been one of its most visually striking mysteries. Instead of forming one clean stream of dust, the tail has bent sharply, split into segments, pulsed, and even produced temporary anti-tail formations, a rare alignment where the tail appears to point toward the sun. These sudden changes imply the comet is extremely sensitive to small shifts in solar wind, magnetic fields, microfragmentation, internal jets, dust grain variations. On December 19th, scientists will finally get continuous, high-resolution imaging of this unstable tail. It will be the first time in history that we can watch an interstellar object interact with the solar wind in real time. A living laboratory drifting millions of kilometers away. Here's something important. December 19th is not doomsday. Nothing dangerous is expected. This is science, not fear. But what if? The comet passes quietly. What if no explosion occurs, no jet activates, no brightness surge appears? Even that outcome would be incredibly valuable. A silent pass would help scientists map the exact shape of the nucleus, identify stable chemical signatures, measure the true rotation period, capture clean thermal data, and confirm how interstellar ices behave under sunlight. In astronomy, most breakthroughs come quietly. Data, patterns, measurements. A calm, predictable pass could answer questions that no spectacular event ever could. But 3, Atlas has not been predictable so far. There are several things that might happen, all scientifically normal, none dangerous. A hidden pocket of volatile ice could suddenly vent outward, creating a temporary spike in brightness. Some interstellar comets naturally break into 2 or more pieces when they warm up. This is rare, but not impossible. A buried jet might ignite when the sun heats a fresh surface layer, altering the comet's path slightly and reshaping the tail. If new jets turn on unevenly, the rotation period may speed up or slow down, a measurable clue about the interior. Spectroscopy could detect complex organics, nitrogen-rich ices, or interstellar radiation products we have never seen in solar system comets. These possibilities excite scientists, not because they are dramatic, but because they carry information. Information about worlds that formed around stars we have never visited. Whether December 19th is calm or active, 3I Atlas has the potential to answer some of astronomy's biggest questions. Are visitors like this rare? Or have we simply not been paying attention until recently? Every gas, every dust grain, every molecule in this object is a message from another planetary system. 3I Atlas may be a fragment from the distant outskirts of a completely foreign star. Radiation, cosmic rays, impacts, thermal cycling, millions of years drifting through nothing. All of this reshapes the surface and maybe the interior of objects like this. December 19th is our best chance to understand how alien worlds weather the galaxy. For most people, December 19th will feel like any other night. If you step outside, you won't see a glowing sky streak, no emerald comet, no fiery tail. Everything happens through instruments. But in observatories around the world, it will be a night of intense activity. Radar beams sweep across the void. Hubble tracks a faint moving speck. JWST turns its golden mirrors toward the coma. Spectrographs capture chemical fingerprints. Supercomputers compare brightness patterns in real time. A global network of scientists working together. Watching a visitor from another star pass briefly through our cosmic neighborhood. For a moment, Earth and an alien object share the same patch of space. Interstellar objects are more than dust and ice. They are relics. They are the debris of ancient worlds, planets that formed, collided, fractured, and were thrown out into the darkness. And every once in a while, one drifts close enough for us to see. 3. CosmiqAtlas is not a danger. It is an opportunity to understand the building blocks of alien planets, to test our models of comet physics, to explore chemistry shaped by stars we have never observed with our own eyes. December 19th is not the end of anything. It is a moment, a brief alignment, when the universe chooses to whisper something to us, a message carried for millions of years, sealed inside a fragment of ancient cosmic ice. And now, we finally get to listen. When CosmiqAtlas passes Earth and continues outward, it will fade back into the darkness between the stars. It will leave behind data, questions, answers, and a deeper understanding of how vast and mysterious our galaxy truly is. We don't know everything yet, but on December 19th, we will know more than humanity has ever known about interstellar visitors. Until then, we watch, we measure, we listen, and we wait for a traveler from the unknown to pass our world one last time.